So to get the ones complement, first you'll write that number in binary. Then if you interchange 0 to 1 and 1 to 0, you can get the ones complement. Next, to get two's complement of a number, what to do? You will start from the least significant bit. You start from this side till you encountered the first one. So it is copied. Once you get the first one, after that you interchange 0 with 1. So this 0 is changed to 1. This 0 is changed to 1. This 1 is changed to 0. This 1 is changed to 0. This one is changed to 0. These two zeros are changed to 1. So in this way you can find out one's complement and two's complement of any number. Also we see these two examples also. Okay. So we have done up to this much in last class. So today we'll go for the sign number representation. How to represent the sign numbers. Okay. So basically we'll try to represent both positive numbers and negative numbers. So the signed number, okay, before going into that, last class also we discussed about unsigned numbers. So we discussed that using n number of bits, we can represent from which number to which number, minimum to maximum.
0 to 2 to
Zero
n minus 1.
n minus
0 to 2 to the power n minus 1. Okay, so with the help of n number of bits, we can represent up to this. So we'll see later on using this signed number from which to which number we can represent. So first of all, this sign number can be represented in three ways. First one is sign magnitude. Next is ones complement method. Next is two's complement method. So using this three representation, we can represent the sign numbers. In all three representation, positive number will remain same. So positive number will be same on all three representation. In all three representation, whatever combinations will assign, that will remain same for the all three representation. Sign magnitude, one's complement, two's complement. Then where they will differ? They will differ only for negative numbers. So in negative numbers, they will differ. So let us see. So suppose we want to represent minus 13. We want to represent minus 13. Okay. So first of all, what to do? We know about the unsigned numbers. So what is 13 actually? How can we present 13? 13 क्या होगा?
1101.
1101. We know that concept of 8421. Okay. Depending upon position, weights are assigned. So 13 is equal to 8 plus 4 plus 1. So it has to be 1101. So we have done this in last class. Okay. Now what to do? Whatever number you want to represent, suppose plus 30 and minus 30. Then what you need to do? To represent the plus number, you need to add another 0. If you want to represent minus 13, you need to add a 1. Okay. So this representation is called as sign magnitude representation. Sign magnitude representation. So what is happening? Here, this most significant bit is your sign. If most significant bit is 0, it represents a positive number. If most significant bit is 1, it represents a negative number. Okay. So is this point clear about sign magnitude? How to represent the numbers, positive numbers and negative numbers?
Yes, sir.
So let us tell then what will happen to by 19. Anyone?
So
1010011.
11
0011.
0011. Okay, great. So same method. First of all, I want to represent 19. So 19 is what? 16. Sorry. 16, then 8 will be 0, 4 will be 0, 2 will be 1 will be 1. So this is your 19. Okay. Weights are 1, 2, 4, 8, 16. So number is 10011. If you want to represent minus, you need to add 1 to before to that. So this will be 110011. If you want to represent plus 19, then what will happen? This will be 0, 10011. Okay. Is this point clear? Is it clear?
Yes.
Okay. Now let me rephrase this question. Now suppose you want to represent this plus 19 and minus 19 using 8 number of bits. Then what will happen? Then what will happen if I'll represent them using 8 number bits?
You have to represent minus 19.
And both I want to represent minus 19 and plus 19. Previously what happened? We used 6 numbers, 6 bits. Okay. Now instead of 6 bits, suppose I want to represent them using 8 number of bits. Then what to do?
10011.
No, what procedure I need to follow? First of all, whenever, how you used to find that? First you are finding 19, then you are either adding 1 and 0 depending upon the sign. So if it is 8 bit now, what will happen? First of all, you will represent this 19 using 7 numbers, 7 bits. Okay. So what will happen? It will become double zero, 206, no sorry, single 0, 1 0, then double 1, double 0, double 1. Already 6 were there. So basically I need to add a, no sorry, 5 sorry, 1 second, double 0. Huh? So basically check this one. I have this 5 bits. So before to that I need to add 2 zeros. So it will become 7 bits. Sign is represented by the most significant bit. So most significant bit will be added here, which will show us the sign. So what will happen to minus 19? Minus 19 will be 1, double 0, double 1, double 0, 1 1. So, गलती हो गया क्या?
वो वहाँ पे 1 शायद नहीं है.
डबल 1 हो गया यहाँ पे सिंगल 1 है 1 double
Yes,
0.
sir. Yes, sir.
Okay. So this will be minus 19. What will be plus 19? Just this one will be replaced with 0. So 0001 00 11. Okay. So now it has a demerit. This representation. First of all, do everyone understood about this representation? Sign magnitude representation.
Yes. Yes, sir.
Okay. Now, one second. Let me clear all this. Now, suppose I wrote this. Okay. So I am representing this number using sign magnitude representation. So what will be this? 000. What will be 000?
Plus 0.
This will be plus 0. 100.
Plus 4.
Minus 0.
Not plus 4. This will become minus 0. This represents the sign. This MSB represents the sign. So this will become minus 0. But do you have plus 0 and minus 0?
No, sir. No, sir.
We don't have. So what happens? Because of this, the way we are representing, because of this, it is creating a problem. What is the problem? Unnecessary one combination is getting wasted. One combination is getting wasted. Okay. So let us see how we can solve that. Okay. So before going into that, okay, as we discussed previously here, that using n number of bits, we can represent 0 to the power n minus 1 if it is unsigned. So now, can you comment using same n number of bits, what I can represent the signed numbers using sign magnitude? Suppose I have 2 bits with me. Okay. Then क्या हो सकेगा? This can be 0 0, this can be 0 1, this can be 1 0, this can be 1 1. What is 0 0? This is plus 0. What is 0, 1? Plus 1. 1, 0, minus 0. 1, 1, minus 1. So using 2 bit, what happens? I represent from minus 1 to plus 1. Similarly, if I'll go for 3 bit, what will happen?
এখন কি করবেন এদের জন্য এখন কি অনলাইন নোটবুক করবেন না অফলাইন কি করবেন আমার তো মনে হয় একবার
What will be triple 0? This is plus 0. Double 0, 1, what will happen?
Plus 1.
Plus 1. This one, plus 2. This one, 0 double 1,
Plus 3.
plus 3. 1 double 0, minus 0. This is minus 1, this is minus 2, this is minus 3. So using 3 bits, I can represent from minus 3 to plus 3. Similarly, you can try it yourself. For 4 bit, it will be minus 7 to plus 7. For 5 bit, it will be minus 15 to plus 15. Okay. So, what will be generalized formula then? Using n number of bits, what I can represent from which number to which number? क्या कर सकते हैं?
Minus 2 to the power n minus 1 minus 1
Minus 2 to the power?
n minus 1 minus 1
Yes, n minus 1 minus 1 to plus 2 to the power n
n
minus
minus 1 minus 1.
Okay, so same place only I am writing. This is for unsigned. So using same n bits, we can represent from minus 2 to the power n minus 1 minus 1 to plus 2 to the power n minus 1 minus 1. This is using sign magnitude. Okay.
सर निगेटिव वाले में -1 नहीं होता है
Negative में
निगेटिव पार्ट में -2 और n-1 से होता है ना सर
sorry ब्रैकेट मिस हो गया ब्रैकेट ठीक है वेरीफाई
नो सर -1 नहीं होता शायद
माइनस
-1 नहीं होता बिकॉज लाइक
हुआ ना
2
चेक
बिट
चेक
में हम लोग -2 से +1 तक रिप्रेजेंट करते हैं ना
यहाँ पे देखो 5 बिट पुट करके देखो फॉर्मूला में ब्रैकेट छूट गया वेरीफाई नाउ
Sir, I got
5 bit 1 second let us clear first that this doubt suppose n equal to 5 so what will happen this will become 2 to the power 4 16 minus 1 15 so minus this will be minus 15 okay is it clear this doubt clear Read
सर
out.
इन फर्स्ट सेमेस्टर लाइक वी स्टडीड इट इज -16 to +15
That will come. Here it is not. Next it will come. I told you this in signed magnitude, this representation. I'm not just talking about binary. If I'm using this representation, as we are defining like this, that this MSB, if it is 0, it is a positive number. If it is 1, it is negative number. So obviously combinations are fixed now. If I'm taking suppose 4 bits, how many combinations are possible? Combination will always 2 to the power n. So how much will be 2 to the power 4? 16 combinations. Okay. Because using this representation, I am getting 2 zeros. So obviously this will become -7 to +7. Yes or no? Because you are getting 2 zeros now, plus zeros and minus 0. Yes or no?
yes yes
So because of this is one of the problem in this. Unnecessary, our one combination is getting wasted. So we'll solve that. We'll go for 2s complement because practically we don't have 2 zeros now. We have only 1 0. We nothing have which is called as plus 0 and minus 0. But the way we are representing, we are getting 2 zeros. Okay. Someone else was asking.
Sir, we can represent 4 as 100 and -0 as 100. So how can we differentiate
Yes.
whether it's -0 or
Suppose
4?
yes, great question. Suppose it is 100. So the system knows that. Means the system should already know that whatever number you're representing, it is an unsigned number or signed number. If system knows that it is an unsigned number, then it is recognized this as 4. If system knows this as signed number, then it will represent this. If it is signed magnitude, it will
Zero.
represent this as -0. Okay. So it is already defined. If it is defined like that, then it will understand this to be, if it is one side, it will define this as to be 4. If it is defined as sine number, it will define this as minus 0.
That's
Okay.
like it will always be predefined, whether it's a
It will
number
be
or it's a
defined.
negative sign.
Either will give the inputs, either will define, or it will be predefined. So
Okay,
we'll
sir.
see when design comes, we'll see about that. Okay.
Okay.
Okay. Next. So first we understood about sign magnitude. Next, let us understand next about one's complement representation. So in all three representation, as I told previously, positive numbers will remain same. Positive number representation will not change. Only negative number representation will change. So suppose if I write plus 6. So what will be plus 6? 6 is what? 110? Yes or no? So plus 6 will be what? This will be 0110. So we define this as sign magnitude. It is also applicable in one's complement representation. It is also applicable in two's complement representation. Whatever is positive number, it remains same irrespective of representation. Same is in sign magnitude, same in one's complement, same in two's complement. Okay. Now, how it differs of representation? They differs only in negative numbers. So in sign magnitude, what we got? We got that minus 6 to be 1110. Similarly, in this one's complement, what will happen? To get the minus 6, you need to take the one's complement of plus 6, this number. If we'll take one's complement of this, whatever combination you will get, you will call them as minus 6. So what is one's complement of this number? 0110.
1001.
1001. So this combination is defined now as minus 6. If it is one's complement, suppose system you are defining them to be a one's complement representation. Then whenever this 1001 comes, system will recognize that it is equal to minus 6. Okay. If it is sign magnitude, this triple one zero will be recognized as minus 6. Whereas one's complement, this 1001 will be recognized as minus 6. Let us take another example. Suppose I want to represent minus 9. Then what to do? First I'll write for plus 9. What will be plus 9? Plus 9 क्या होगा? How much will be plus 9?
1001.
1001. ये खाली 9 हो गया.
जीरो जीरो के साथ होगा,
You
एक आगे
need
जीरो
to
होगा.
put 0 before that. Okay. Plus 9 is this. This one is sign. This one is the magnitude. To get the minus 9, just take the ones complement of this. This will become 10110. Okay. So this is the minus 9 in ones complement. Same minus 9. In sign magnitude, what will happen? This will be just this 0 will be changed. 1, 1, 0, 1. This is in sign magnitude. Okay. So same example is given here. You can check two examples. 13 minus 13. If you just take one's complement of this, you can represent the minus 13. Similarly here, minus 45. To write that in one's complement, you can take the one's complement of this plus 45. Okay. So is it clear how to represent negative numbers using one's complement method? Is it point clear?
Yes, sir.
Okay. Let us see now whatever the problem we faced in sign magnitude, that problem is solved or not. Verify and tell. Is that problem solved using this representation? Is this problem solved? देखो प्लस 0 माइनस 0 का प्रॉब्लम हो रहा है क्या? Is it solved, this problem?
No, sir.
Not solved. How? We know that from plus 0 to 7, it has to be remain same irrespective of all representation. So plus 0, suppose we know that it is suppose 40. So what will be minus 0? It should be 1's complement of this. What is 1's complement of this? 4 ones. So a combination exists which will be equal to minus 0. So using this also we are unable to solve this problem. Using sign 1 also we are unable to solve this problem. So how can we solve this? We can go for the next one, which is called as 2's complement representation. So again it is similar in only similar thing. So only thing is again same example of plus 7. What is plus 7? Or let us take plus 7 is 0
111.
triple 1. Okay. So plus number remains same for all representation, both sign magnitude, 1's complement, 2's complement. Okay. Now to represent minus 7, what you need to do? You need to take the 2's complement of this number. You need to take the 2's complement of this number. What is 2's complement of this? We'll start copying from least significant bit. First one is already encountered, so other bit needs to be interchanged. So 1 will be changed to 0. This one will be changed to 0. This 0 becomes 1. Okay. So what happens? This minus 7 will be represented with the help of 1001. Represented with 1001. Okay. Let us take another example. Suppose 11. Let us represent minus 11 using all three representation.
So,
Okay. Yes.
so minus 7 is 1001 using 2's complement, right?
Yes. So let us represent minus 11. Minus 11. So first of all, I need to represent 11. 11 is what? 8, 4, 2, 1. 11 is 1011. Okay. So what will be plus 11? Plus 11 will be 0, 1, 0, 1, 1. ठीक है? So this will remain same for sign magnitude, 1's complement, 2's complement. Now, what will be minus 11 in sign magnitude? What can I write?
1101.
Just the 0 will be changed with 1. Others will remain same. Same minus 11. If I'll write in 1's complement, what can I write? I need to take the 1's complement of plus 11. Then what I will get?
10100.
1. This 0 will be changed to 1. This one will be changed to 0. This 0 will be changed to 1. This one will be changed to 0. This one will be changed to 0. To represent that minus 1 using 2's complement, I need to take the
10101.
1 second. To take the 2's complement of to find the 2's complement of this, we start copying from this side 1. First one is encountered, then other bit needs to be interchanged. So 1 will be changed to 0, 0 will be changed to 1, 1 will be changed to 0, this 0 will be changed to 1. Okay. So this number will be minus 11 using 2's complement. Okay. So now let us check, verify the same number plus 0 and minus 0. What is happening? What will be 4 zeros? What will be 4 zeros?
Plus 0.
Plus 0.
Plus it.
Again, same method. What will be its 2's complement of 4 0?
0, 0, 0, 0.
0, 0, 0 only. So this is only in same way. This is only 1 0 only. So unnecessarily one combination is not getting wasted. One combination is not getting wasted. So what will happen? Using this sign 2's complement, we are only getting 1 0 here. 1 0 here. So again, because we are using suppose 4 number of bits, then only 16 possible combinations are there. And we are able to represent from 0 to plus 7. Okay. So Exactly, if you look into this, what will happen here now? In negative, you will be able to represent from -1 to -8. That's some doubt someone was asking previously. Okay. So because of this, what will happen? Here, if we use n number of bits, as there is no negative 0 here, what will happen? We can represent from -2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. Okay, so these are the different representation, and using n number of bit we represent from this to this in 2's complement, and sign magnitude this, 1's complement also this, unsigned number this. Okay, then why you are doing all this stuff? Just to make our, in last class I told, just to make our subtraction problem into a addition problem, so that it will become a one operation. We don't want to be subtract. If somehow we can make subtraction into addition problem, then with one circuit we'll be able to perform both the task. So how can we do? Suppose that example I gave, suppose I want to find a minus b. So instead of a minus b, I can write like this. This is plus a. So plus a plus minus b. I know how to represent minus b. I know how to represent plus a. Then the subtraction problem becomes a addition problem. This becomes a addition problem. So we have only this. How to do this 2's complement arithmetic. Okay, how to do this using 2's complement method. So there are certain rules for that, how we can perform this. So to first find a minus b, basically what we are doing? We are doing plus a plus of minus b. So how we will represent minus b? What is the method? How we are representing negative number? In 2's complement, how we are representing this? कैसे किया थे अभी? Suppose -7. How we represented that?
2's complement of plus 7.
2's complement of plus 7. So what to do? Here we need to take the 2's complement of b, 2's complement of this b. So same thing is mentioned here. To find a minus b, you add 2's complement of b with a. A is already positive number. If we take 2's complement of plus b, this will represent minus b. Okay, then we need to add this 2. After adding, if there will be a carry in the end, if there is carry in the end, then you discard that. Then you discard that carry. That carry is called as end around carry. Whatever carry you are getting in the end. And we need to check the most significant bit. Two possibilities are there in the most significant bit. It can be 0 or it can be 1. If most significant bit is 0, then your result will be in positive. Result will be in positive. If MSB is 1, that means what? The result is negative, because as you can see in that table, every time positive number means what? Your most significant bits are 0. Negative number means your most significant bits are 1. Okay, so if MSB is 1, result is negative. But there is another issue. Suppose question comes, what is 15 minus 7? What is the answer of this? It is 8. But whenever we are doing this adding and this everything we are doing in binary. But for our exam point of view, we need to write that answer is equal to 8. So suppose question is that now if it is plus 8, no issue. It will be in its true form, because directly from here, anyone if you observe, you can directly tell, suppose this one is the answer. By looking into this, you can say that this is equal to plus 5. But suppose this is your answer, 1010. Okay, then what is 1010? 1010 is minus 6. 1010 is minus 6. But from this, how can you say that this is equal to minus 6? Now I have to see in the reverse direction. Are you getting the problem?
Yes, sir.
If you are representing minus 6, you are going in the right way. So from minus 6, you are saying that this is equal to 1010. Now the question is, if you have with us 1010, I need to tell this is equal to minus 6. Then what to do? So there is a way for that. What to do? You need to take the 2's complement again. You need to take the 2's complement again. Okay. So what will happen if we take 2's complement of this? 0, then 1 is not encountered yet, so I will keep on copying. Next is 1. Okay.
1 0.
Next, 0 will be changed to 1, 1 will be changed to 0. So, if we will now find this decimal number, what is this? This will be 6. 1 second. No need to take this sign also. 1 second, otherwise unnecessarily will get confused. 1 second. This is 1010. So, first of all, you can remove this one. Okay, you can remove this sign bit, most significant bit. Then you can find the 2's complement. Then you can find the 2's complement. So this will be 0, then 1, then you first one is encountered. So this 0 needs to be interchanged. What is 110? Its weightage, its value in decimal 110, 6. Because this is, now I have converted this, I need to add a negative sign before this. Because it's a negative number, I am going backwards to find out. So whatever this comes, this is your minus 6. Okay, so exactly same thing we need to do it here. So with an example, it will be clear. Now suppose question is, I need to find 25 minus 14. 25 minus 14. So what will happen? 25 minus 14 means what? I can write this as 25 plus minus 14. Okay, this is plus 25 plus minus 14. So first of all, I need to represent what is plus 25. So what is plus 25? Suppose I need to represent it with 8 number of bits. Then what to do? What will be plus 25? कितना होगा? 1, 2, 4, 8, 16, 32.
0 1 1 0 0 1.
I need to take 7 number of bits. So 1, 2, 3, 4, 5, 6, 7. 25 is 16 plus 8 plus 1. So this will be 0, 0, 1, 1, 0, 0, 1. To represent plus 25, I need to add a 0. This will be my most significant bit. So this will be 000, 11, 001. Okay. Next. I want to represent minus 14. For that, first of all, I need to write plus 14. What will be plus 14? 14 is what? 8 plus 4 plus 2. So 8, 4, 2. Other places will be 0. This most significant bit represents the sign. As it is plus, this has to be 0. Next. To write minus 14, what I need to do? I need to take 2's complement of this number. I need to take 2's complement of this number. So what to do? 0, copied. 1 is not encountered. Next checked 1, copied. So first one is encountered now. Once first one is encountered, then what to do? Other bits will be interchanged. So what will happen? This one will be changed to 0. This one changed to 0. This 0 changed to 1. 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 So what happens? It is 410010. 410010. Plus 25 is 0001101. Next what to do? Next we need to add this 2. So what will happen? 1 plus 0, 1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 1, how much will be 1 plus 1?
0.
Not 0. Sum 0.
One carry है.
Carry 1. Okay. Again 1 plus 1 plus 0. So again sum 0. Carry 1. Again 1 plus 1 plus 0. So again sum 0. Carry 1. Again 1 plus 1 plus 0. What will happen? यहीं पे मिस हो गया 1 सेकेंड 3.6 7 यहाँ पे मिस कर दिया मैंने 1 सेकेंड ये लाइन मिस हो गया लेट मी राइट इट हियर तो मिसमैच है वहां पे -14 इज दिस +25 इज दिस 000 11 001 ठीक है what happens 1 plus 0 1 this 1 plus 0 1 0 plus 0 0 0 plus 1 1 this 1 plus 1 is sum 0 this carry is 1 now 1 plus 1 plus 0 sum 0 carry 1 1 plus 1 plus 0 sum 0 carry 1 1 plus 1 plus 0 sum 0 carry 1 so here we have 8 number of bits so when I add both of them what happens I got a carry in the end this is called as end around carry okay so what happens here if you got a end around carry you need to discard that so I am removing it okay after removing this what to do I need to check the most significant bit what is the value of most significant bit now
0.
this is 0 so if it is 0 means it is a positive number okay so it is in its true form so can you write this number what does 401011 represents so
Plus 11.
this represents the plus 11 which is also correct 25 minus 14 is plus 11 okay now let us do the opposite let us solve a question for the to get the negative answer okay let's do the same part let us just reverse this so let us solve for 14 minus 25 14 minus 25 so what will happen plus 14 तो हो गया है already 1 second so plus 14 minus 25 is nothing but plus 14 plus of minus 25 plus 14 we already done here to represent minus 25 what to do I need to write the 2's complement of plus 25 what will be 2's complement number is here क्या होगा 2's complement of this
1 1 1 0 0
1
1 1 1
first one is encountered
0
okay so first one encountered other bit needs to be interchanged this is 1 this is 1 this is 0 this is 0 this is 1 this is 1 this is 1 so I am removing this plus 25 no need to write it now next I need to add them so if I add them what I will get 1 plus 0 1 1 plus 1 sum 0 carry 1 1 plus 1 plus 1 what will get 1 plus 1 plus 1 sum 1
Someone
carry 1
carry 1
again 1 plus 1 sum 0 carry 1 1 plus 0 plus 0 1 1 plus 0 1 1 plus 0 1 1 plus 0 1 so first of all did you get any end around carry we didn't get end around carry here what was 8 bit here also we got 8 bit so we are not getting anything extra next I need to check the sign of the bit and most significant bit so what is it 0 or 1 sign
1
1 so 1 means what it is a negative number
negative
okay so for a system actually what this is your final answer this is your final answer but for exam point of view we need to show that 14 minus 25 is minus 11 so it is only minus 11 but from this number how to know that it is minus 11 so what to do again you need to take the 2's complement of this number so if we take 2's complement of this what will happen 1 comes here first one is encountered, then other bits needs to be interchanged. So 0 will be changed to 1, 1 will be changed to 0, 0 will be changed to 1, others will be changed to 0. Okay, then what is the decimal equivalent of this? This is 1,
11.
this is 2, this is 4, this is 8. Others are 0, so I'm not writing. So 8 plus 2 plus 1 is 11. And I need to put a negative sign before this. So whatever I am getting here, that is equal to minus 11. Okay. So similarly, there is a task for you. You should do the other things also. You should try to do this minus 14, minus 25. Okay. Exactly same method you need to follow. Minus 14, minus 25. तो क्या करना होगा इसके लिए? Minus 14, minus 25 के लिए.
Minus 14 plus minus 25.
So now this is minus 14 plus minus 25. So we need to take 2's complement of both the numbers. Now suppose question comes minus 40 minus of minus 25. Then क्या करना होगा? So minus minus becomes plus. So this is
Yes,
basically
minus 14 plus
25 minus 14. That means 25 plus of minus 14. You can do this. Okay. So try to do this kind of problems and refer to some problems in the book also. Okay. So same examples is given here. Okay. Okay, let us stop up to this. In the next class, we'll proceed to the next part. Okay.
Okay, sir.
One second, let me take. Don't leave the meeting.